At this point, you're familiar with congruent triangles. We learned that congruent triangles have the same size and the same shape. Today we're learning about something a little different. They're called similar triangles. Now, two polygons are similar if and only if their corresponding angles are congruent and the measures of their corresponding sides are proportional. Now, corresponding, we saw this word in congruent triangles, and remember that it means order matters. You have to be a very organized mathematician and make sure that you're following the same order for every step that you take in the problem. So basically, two polygons are similar if they have congruent angles and their sides and the corresponding sides are proportional. Okay, those are the two main things that you need to know. The symbol for when two things are similar is the tilde that you're familiar with in Spanish, right? So if I wanted to write that two triangles are similar, I would write triangle ABC is similar to triangle DEF. And I would put the symbol right here like that. Okay. So over here we have an example of two similar polygons. As you can see, one is small and one is larger. And this smaller one is just a smaller version of the bigger one. So think of the bigger polygon as kind of like the parent or the adult, and the smaller one is the baby or the child. They look the same, but they're different. So down here, the first thing that we go over is the similarity statement. And this is the most important statement because it tells you exactly what angles are congruent to one another and what sides are proportional to one another. So if you look at the similarity statement here, we can see just from the statement alone that angle A is congruent to angle E, which is over here. We can see that angle B is congruent to angle F, angle C is congruent to angle G, and angle D is congruent to angle H. This is all just from the similarity statement. So the similarity statement is extremely important. We can also see what sides are corresponding. AB is the first two letters in the first polygon, and that is corresponding to side EF in the second figure. So let's say we called these E, F, G, H. Now I'll be able to show you what I'm talking about, right? So AB and FE are corresponding sides. And we learned that just from looking at the similarity statement. BC is corresponding to FG. CD is corresponding to GH. And AD corresponds to EH. AD corresponds to EH. So this is all the information we can get just from the similarity statement. And these sides right over here, if we were to compare corresponding sides with one another in a proportion, they'll all equal the same scale factor. And that's the amount that you multiply the smaller figure by in order to get to the larger figure, or vice versa. That's the scale factor. So let's just do a few little problems, okay? So on page 73 in your packets, this is number 1. Let the similarity statement be your guide. However, the similarity statement isn't written in the way that we're used to, so I'm just going to rewrite it, okay? It says, find X if triangle ABC is similar to triangle EFG. Oh, perfect. Okay, now my similarity statement is written. I'm good. Okay, so I know that similar triangles have 3 sets of corresponding congruent angles. And my similarity statement should back these up. Angle A is congruent to angle E, Angle B is congruent to angle F, and angle C is congruent to angle G. And that is reflected in the picture below. So if I know that angle B is congruent to angle F, and angle F is 105 degrees in measure, angle B, or X, must also be 105 degrees. And the property that this represents is that in similar figures, corresponding angles are congruent. Okay. Next, this is number 2 on page 73. The problem says, find X if triangles ABC and EFG are similar. Okay, so I'm going to rewrite the similarity statement in a way that I am familiar with. Triangle ABC is similar to triangle EFG. Okay, so I know angle A is equal to angle E, angle B is congruent to angle F. Well, actually, see, I committed a cardinal sin. I assumed something that was not given. I don't know that those are 90-degree angles. So I'm just going to say that the angles are congruent, whatever they may be. And angle C is congruent to angle G. Okay, let's do a little colors down here so you can see. All right, so I just learned so much from my similarity statement. Now, if all of the sides, all of the corresponding sides in similar triangles are proportional, I can set up a proportion in order to find X. Let's start with side FG, okay? Side FG over here. Side FG are the last 2 letters in the second triangle. So let's look for the corresponding side, which is going to be the last 2 letters in the first triangle, or side BC. So now I can set up a proportion where 20 is to 5 as, let's find our second ratio. I'm getting a different color going up in here. All right, here we go. Side FE corresponds to, it's the first 2 letters in the second triangle, so the first 2 letters in the first triangle are A, B. So 16 corresponds to X. Now, I started with the measure from the large triangle, so I have to continue with the measure from the large triangle. You always use the measure from the same triangle first, and then set it equal to the corresponding side on the second triangle. So I always take from the first triangle and the second triangle. I can't ever switch that, okay? So now I cross multiply, and I get X equals 20x equals 80 divided by 20. X equals 4. Okay, now let's do this problem. Find X if triangle ABC is similar to triangle DBE. Okay, so first we have to find what is congruent to what. Now, my similarity statement says triangle ABC is similar to triangle DBE. So given this similarity statement, I know that angle A is congruent to angle D, angle B is congruent to angle B, which makes sense because they're vertical angles, and angle C is congruent to angle E. Okay? So now I have my figure all marked up. Let's set up a ratio. So in the second triangle, side DB, well, now that blocked the thing, hold on. Side DB are the first 2 letters. The first 2 letters in the first triangle are AB, so the corresponding side is going to be AB. So let's set up our first ratio. 10 is to X as, okay, let's look at our other figure, our second set of sides. We have side BE. Side BE are the last 2 letters in the second triangle. The last two letters in the first triangle are BC, so the corresponding side is going to be BC, which is 5. Now I started with the bottom triangle, I have to continue with the bottom triangle. My ratio is now 20 is to 5. Cross multiply, I get 50 equals 20x divided by 20 divided by 20, x equals 2.5. Okay, now let's do this other one over here. Oh, what is the property that we're using? The property that we're using here is that corresponding sides are proportional. Okay, don't forget to write in the property, sorry. Okay, so on this next one here, it says, find x if triangle ABC is similar to triangle EDB. So again, I'm going to write it in a way that I recognize that, which is ABC is similar to triangle EBD. Okay, so using the similarity statement as my guide, I know that angle A is congruent to angle E. I know that angle B is congruent to angle B, makes sense, vertical angles. And I know that angle C is congruent to angle D. Okay, now let's set up our ratio, okay, in order to find x. So let's start with this side, side DB, okay? DB. DB is the last two letters in the second triangle. So the last two letters of the first triangle, or the corresponding side, is going to be BC, okay? So 10 is to 5. Let's find the other side. We have BE, which is equal to 20, corresponds to the first two letters in the first triangle, which is AB, which is x. So I'm going to cross multiply, and I get 10x equals 100 divided by 10 divided by 10. I get x equals 10. Now, I really want you to see something right now. This one is literally the exact same figure as this one, only the similarity statement is different. Look at the similarity statements, okay? This similarity statement is different from this one. It looks like the DBE order over here, this order here, was switched around, okay? And look, it gave us completely different answers for x. Completely different answers for x. So this just shows the power, the power of the similarity statement. And I want you to write it every single time. You need to write your similarity statement every single time. Got to write it every time. And remember, the similarity statement is the statement that looks like this.